Good morning. In this video, we are going to learn how we can integrate a fraction of polynomials. Most specifically, how do we integrate a proper fraction of polynomials? And by proper fraction, we mean that the degree of the numerator is strictly less than the degree of the denominator. So in our case here, the degree of the numerator is 1 and the degree of the denominator is 2. First of all, what you do is you check if the numerator is the derivative of the denominator or a constant multiple of the derivative of the denominator. Why? Because if it is, we can go to the form of integral of u prime over u dx, which is equal to ln u. And I have another video explaining the absolute value of u. I have another video explaining how we use this rule, and I solve multiple integrals in it. So here, the derivative of the denominator, it's 2x plus 2, but the numerator is x, so it's not a constant multiple of the denominator. So we are not in this case. So what we do now is that we search for the roots of the denominator in order to decompose this fraction into partial fractions. So we search for the roots of the denominator. So I'm searching for the roots of x squared plus 2x minus 3. It's a second degree polynomial of the form ax squared plus bx plus c. I'm solving this equation equal to 0 in order to find the roots. So here you can find the roots using two methods. If you check here, we have a plus b plus c equals 0 because 1 plus 2 minus 3 is equal to 0. So the roots are 1 and c over a, so 1 and minus 3. Or you can search for delta, which is b squared minus 4ac, which is, in this case, 16. And the roots would be minus b plus minus square root of delta over 2a. And they are going to be, again, minus 3 and 1. Now, when we find the roots of the second degree polynomial, which is the denominator, we write it as a factor of these roots. Now, in case that this denominator doesn't have any real roots, this is another video that you can watch, and the integral, we would be completing the square and we will solve the integral in order to get tangent inverse. But this is another video that you can check. All right, getting back to here, we have the roots which are minus 1 and minus 3. So my denominator can be decomposed into x minus 3 factor of x plus 3, not decomposed, but written as factors. Now we decompose our fraction of polynomials into what we call partial fractions. So the first partial fraction would have the denominator, the first factor, which is x minus 1, and the second one would have x plus 3. And always the degree of the numerator in the partial fractions is 1 degree less than the denominator. So here, if I have a degree 1, it's going to be of degree 0 here. So it's going to be a constant. So the decomposition here, it's going to be a over x minus 1 plus b over x plus 3. Now, there are two ways for finding a and b. The first method is to take, again, the common denominator and to identify with x. And the other method, which is much, much easier, is the cover-up method, and which we can use here. We can use the cover-up method because here we have linear factor. I explained the cover-up method in details in another video. But to explain a little bit quickly here, so the denominator in the partial fraction of a is x minus 1, so we cover x minus 1 on the left hand side, or we delete it if you want, and in what remains we replace x by 1 because it's the number that makes x minus 1 0, so we get 1 over 1 plus 3, which is 1 over 4. Now to find b using the cover up method, we cover or we delete x plus 3, we delete the denominator in the partial fraction of b, and in what remains we replace x by minus 3, so we get minus 3 over minus 3 minus 1, which is 3 over 4. And now we have a and b, which means our integral becomes integral of 1 over 4 becomes integral of 1 over 4 over x minus 1 plus 3 over 4 over x plus 3, which are a and b. And then we write it as two separate integrals. So 1 over 4 integral of 1 over x minus 1 plus 3 over 4 integral of 1 over x plus 3. Now these are of the form u prime over u. One second. These are of the form u prime over u because the derivative of x minus 1 is 1. So it's integral of u prime over u. Again, here it's integral of u prime over u, which is ln absolute value of u. And our final answer would be 1 over 4 ln absolute value of x minus 1 plus 3 over 4 ln absolute value of x plus 3 plus a constant c. Don't forget to subscribe to our channel, and if you like my videos, don't forget to push the like button. Thank you for watching.